Okay, so we are to Unit 4, Lesson 3. And this transformation that we're going to learn about today is a rotation. So a rotation is a transformation where we turn a figure around a fixed point, and that point is called the center of rotation. We can rotate things any amount of degrees we want. That angle we rotate is the angle of rotation. So a rotation rotates a figure around a fixed point. If we rotate something 360 degrees, we're back to where we started. So a rotation does not change the size or the shape of an object. So all this little diagram right here does is tells us if Q is not the center of rotation, then this distance between Q and P is the same as the image, okay? If Q happened to be the center of rotation, then Q is just that fixed point. Q doesn't change at all. So it's kind of like an arm that's rotating. So what we're going to talk about is rotating figures different amounts of degrees. So in our first example, we are rotating this triangle 180 degrees around the origin. So I am going to show, all right, I'm going to show that the origin is our center of rotation, and I'm going to graph our triangle first. So this point I graphed is just the center of rotation. So the point 3, 1, 3, 4, and 1, 1. So that's, I missed A here, sorry. A, B, C. And I'm going to connect those points to form a triangle, okay? So 180 degree rotation, we always think of these rotations as being counterclockwise. But the thing is about 180 degree rotation is that it really doesn't matter which direction you go. If I turn 180 degrees to the left or to the right, I'm still going to be facing behind where I originally was facing. So 180 degrees, the direction really doesn't matter. But from that purple sheet with the rules, 180 degree rotation of 180 degrees, what that does is it takes X and Y, it takes our points, and all it does is it changes the sign of both our points. It doesn't just make them negative, it changes the sign. So point A, the image of point A is going to be -3, -1. The image of point B is -3, -4. Okay? And the image of C is -1, -1. So I'm going to graph those in a different color to show a 180 degree rotation. So -3, -1, -3, -4, and -1, -1. So we've got A image, B's image, and C's image. So that's me rotating, I'm going to do this in green, 180 degrees counterclockwise. So that's 180 degrees. It's the same as going 180 degrees clockwise, but counterclockwise is this direction, okay? So by default, unless I say different, we'll say counterclockwise. All right, that's the default for transformations that are rotations. In example 2, we're going to perform a composition, which means we're going to be performing 2 transformations. So I'm going to graph my image, or my pre-image of RS, and that is R is 1, -3, and then S is 2, -6. So R, S. I'm going to connect those points. I'll use red. That is my pre-image. So my first transformation is to reflect over the y-axis. So I'm going to use blue to show that. The y-axis is that vertical axis. So me reflecting this over the y-axis puts R right here and S right here. So remember, reflecting over an axis is pretty much just counting. If it was 1 to the right, it's 1 to the left. If it was 2 to the right, it's 2 to the left. What I really want to show here is us transforming the image of R and the image of S. So if I'm going to rotate this 180 degrees about the origin, it's just using that rule we had before. So our image of our image is going to be 1, 3, and then 2, 6. Remember, rotating 180 degrees just changes the sign. So I'm going to do our image of our image, our final destination here, at 1, 3, and 2, 6. And I'm going to connect those points. So R with 2 markings, S with 2 markings. That shows that we did 2 transformations. So it's doing 2 transformations in a row. If you need to work it out, I'm trying to give you enough space for that. Okay? So, moving ahead. The next thing. And I'm going to give you guys some practice, and I'm going to help you out with some of these rotations. But rotational symmetry. A figure has rotational symmetry if we can rotate it kind of onto itself. So, if I can rotate by 180 degrees or less, it has rotational symmetry. The point is the center of symmetry. So I think I must have messed something up here. But the point in the middle, if you look at this pinwheel type thing, this point in the middle is the center of rotation. Okay? So the rotation can be clockwise or counterclockwise. It doesn't matter. But the figure below here, it has rotational symmetry because I can rotate it 90 degrees and it maps it onto itself. So it just shows 45 degrees, doesn't really do that. It's got to be in this position, this original position, and have the blades showing the same direction. So if I rotate it 90 degrees, it is back to its original position. So I'm going to use this last example to show you some examples of rotational symmetry. So if I look at this triangle is an equilateral triangle. If I rotate this around this imaginary kind of fixed point here, this does have rotational symmetry. And if we look at it, it's got 3 kind of points where if I turn the triangle this far, it would map it onto itself. If I turn it again, it would map it onto itself. If I turn it again, it'll map it onto itself. So that's 3 kind of equal turns degree-wise that would show that rotational symmetry. So the rotations that map it onto itself would be 120 degrees. You could go 240 degrees, another 120, and then, mapping it onto itself. So you could just go by 120 each time because there's 3 equal turns for 360 degrees. 360 divided by 3 is 120. So I can turn this 120 degrees at a time to get that rotational symmetry. In part B, this does not have rotational symmetry. There's no way I could rotate this 180 degrees or less and map this triangle onto itself. There's no way. So you got to be able to see some sort of symmetry there. Then in part C, if I rotate this, you think about kind of on a fixed point. If I rotate this, 180 degrees, this would map onto itself. So yes, this has rotational symmetry, and I can turn this 180 degrees at a time. Because if I kind of think about spinning this around, this point would land here. This segment would match up with that segment. It would map onto itself. So that rotational symmetry, you're looking for it to be able to turn onto itself 180 degrees or less at a time. So I know that I kind of limited you on the amount of rotations, so use that transformation sheet to help you with the practice, and use me as a resource to help you with some of these transformations, because it's important that you use the rules to write out your work for these transformations.